and welcome to today's lesson. Today we're going to look at the last algebraic technique for solving quadratic equations. And that technique is called the quadratic formula. And here I've written a generalized quadratic equation. ax squared, where a represents some number, plus bx plus c, and b and c are also representing numbers. What we're going to do is we're going to approach this, try and solve it using completing the squares, and then come up with what we think might be a very practical formula that allows us to solve in a more direct way. So I'm just going to develop this formula that we'll call the quadratic formula and show you how we get this formula. First of all, if I was going to use completing the squares, I'd want to get rid of this a in front of the x squared. So I'd divide everything by a, just like that. So what would that look like? Well, we'd have the a's cancel, and I've got x squared. Then I'd have b over a times the x, and I'm going to move this guy to the other side. And on the other side, there's just a 0 anyway, so I'm going to move it over and get negative c over a. Now, the method of completing the squares, to complete the square, what we had to do was take half of this number and square it. So half of b over a, well, that's b over 2a, and b over 2a squared, that's the number that we want to put in here. So we're going to have b squared all over 4a squared. And what we add to the left side, we have to add to the right side. Okay, so there we have it. We're ready to now put this completed trinomial into its factored form. So we're going to have x, and then we just take half of this number, that's the one that we want to put in here now. So that's going to be positive b over 2a, all squared. And over on this side, it would be very nice to combine these with a common denominator. Well, we're going to have to build this one up to being a 4a squared. So I'll have to times the top and bottom by 4 and a. So what are we going to get here? Well, we're going to have 4a squared on the bottom, and we're going to have a negative c times 4a and a positive b squared. So I'm going to write those as the positive first, b squared, and then the negative 4 times a times c. So we've combined the fraction. Now we're going to square root both sides of the equation. Give myself a little more room here. When I square root, that's going to undo the squaring. So I'm going to be left with x plus b over 2a. And on the right side, I'm going to end up with plus or minus. Now, there's not much I can do about the top, so I'm just going to write that as the square root of b squared minus 4ac. And on the bottom, I can figure out the square root of 4 and the square root of a squared. Square root of 4 is 2, and the square root of a squared is a. Now I'm ready to solve for x. So I'm going to subtract the b over 2a to the other side, and so x looks like this. We have a negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So we end up with this. It does have the same denominator, so 2a on the bottom, we have negative b plus or minus the square root of b squared minus 4ac. This is the quadratic formula. What we're doing is, if we have a quadratic equation of this form, ax squared plus bx plus c equals 0. Notice it has to equal 0. And we want to solve for x. all we have to do is identify what is the coefficient in front of x squared, and we're going to put that in where the a's are. What's the coefficient number in front of the x? Well, that's b, and we're going to put it where the b's are. And what's this constant term at the end? That's c. We're going to put that where the c is. And that's all there is to it. It makes it very quick and very easy to solve quadratic equations. Let me just show you how easy this really is. Suppose we had one that was all set up and ready to go in this form. Something as simple as 3x squared plus 5x minus 2 equals 0. So we're happy. It's in this form here, equal to 0. We've identified a, b, and c. We can just go ahead and say, well, x is going to be negative b. Now here's b. It's a positive 5. So negative b would be negative 5 plus or minus the square root of b squared. b is 5, so 5 squared is what we're going to put in there, minus 4 times a, I'll give myself a little more room, a is 3, and times c. c is negative 2. The only thing you have to watch is the signs. Remember to consider c here as a negative 2. And that's all over 2 times a. a is positive 3. Well, all I have to do now is simplify this out, and there's my answer. So let's get rid of this. And we've got negative 5 plus or minus the square root of 25. Now here we have a minus, but we're also timesing these numbers, and one of which is negative. So this is going to be 25 plus 4 times 3 is 12. 12 times 2 is 24. All over 2 times 3 is 6. So now we have negative 5 plus or minus the square root of 49, which is 7. All over 6. And what are my answers going to look like? Well, we're going to have negative 5 plus 7, which is positive 2 over 6, which of course would simplify down to 1/3. But we'll also have negative 5 minus 7, which is negative 12 over 6, which simplifies down to negative 2. So my two solutions would be positive 1/3 and negative 2. So very little work, very direct and succinct, right to the point, we get our solutions. Sometimes the real work when you're using the quadratic formula or factoring or completing the square or for that matter even graphing, sometimes there's a lot of preliminary work until you get the equation in this form here. So that's what I'm going to do with my next example. The next example, I'll give myself adequate room here. What we've got is 2 over x plus 1 plus 3 over x minus 2 equals 2x squared divided by x squared minus x minus 2. Okay. So clearly this is not in the form of ax squared plus bx plus c equals 0. So our work is to clean this mess up. The first thing that I notice here is that this trinomial could be factored, and that might make our job a little easier. So, in its factored form, it would look like this. I need numbers that make negative 2 that add up to positive 1. That make negative 2 that add up to negative 1. So I'm going to go with negative 2 times positive 1. And just confirm that it works. X squared, check. Positive 1x, negative 2x adds up to negative 1x, check. And negative 2 at the end, check. So I'm going to rethink that and replace it with this factored version. Why is that helpful? Because now I want to get rid of all these fractions. And I have less work to do because of the factoring. I'm going to multiply each and every term here, this whole thing, by an x plus 1 and an x minus 2. So an x plus 1 and an x minus 2. That's what I'm going to multiply each and everything by. So what's going to happen is the first term times these two, well, the x plus 1s will cancel. I'll be left with a 2 and an x minus 2. Then I'll have plus. Now the x minus 2's will cancel, and I'll be left with the 3 and the x plus 1. And the last term is really nice. Everything cancels with the binomials that I'm multiplying by, and I'm only left with 2x squared. Well, now I'm going to reorganize things, expand the brackets, and move everything probably to the right side, because it's really nice to keep the coefficient in front of x squared positive. So what do we have? 2x and minus 4 plus 3x plus 3 equals 2x squared. Let's move everything over, and so what we're going to have here is 2x and 3x makes 5x's, so I'll subtract the 5x over to this side. And we have negative 4 and 3 makes negative 1, so I'm actually going to add 1 over to this side. So we still just have now the 0 there. So here's the equation that we're left with. You can think of the 0 equals, you can move that if you like over to the other side. Sometimes it looks just a little bit more familiar to us if we put equals 0 on the right side. There it is, all cleaned up, ready to go. Let's use our quadratic formula and solve this thing. You may find it useful at the start anyway to just write down what is A, B, and C. A is 2, B is negative 5, and C is positive 1. So that kind of, just to make sure I don't get my signs mixed up. Okay, over to the quadratic formula, let's solve for x. First thing we have to do is negative b. So we're going to have negative 5 plus or minus the square root of b squared. That's going to be negative 5 squared minus 4 times a, so 4 times 2, times c, which is 1, all over 2 times a, which is 2. So there it is. I just put everything in place, and let's work it out. Double negative makes a positive, so that's just 5, plus or minus the square root of. Well, what do we have here? We have 25 minus 8. 25 minus 8, 17, and a 4 on the bottom, and there's nothing I can do to simplify that further. That's my answer. So very quick, very nice working with the quadratic formula. We can leave it in this form. Again, these are exact numbers. If a question requested that these be decimals, we could certainly work these as decimals. And just a little hint there, to get the decimal version on your calculator, just remember, it's the entire top divided by 4. So I would recommend you use a bracket and then go 5 plus the square root of 17, close the bracket, and then divide by 4 to get the one decimal solution. To get the other decimal solution, again, use brackets, and it will be 5 minus the square root of 17, close the bracket, divide by 4. And that's if you want to get the decimals. I prefer to leave them as exact solutions. So there you have it. That is the quadratic formula and what it